Now we will talk about fifth lecture on module 3, which is on quantitative risk assessment. In the last two lectures we discussed about chemical exposure index method. We discussed couple of problems to know how to do a chemical risk analysis for gas and vapor release models. Today we will discuss about something on liquid release models in detail. We will talk about liquid release models today. Before that, let us quickly summarize once again for our own interest world disasters which occurred in oil industry. We have already discussed many case studies in the first module. Just for the interest we will summarize once again them. Oil tanker Torney Canyon grounded in English Channel 1967, UK production platform Piper Alpha disaster occurred in 1976, the capsize of the Norwegian accommodation platform Alexander Kielland occurred in 1980, the Exxon Valdez oil spill occurred in 1989, the pipeline rupture in Yunsk area Russia occurred in 1994, Buncefield fire occurred on 11 December 2005 at Hertfordshire oil storage terminal, and Gulf of Mexico BP oil disaster which occurred in 2010. We have already understood the necessity for revising these kind of accident scenarios occurred in oil industry. Let us quickly revise what do we mean by the necessity for safety. High growth in industrialization in the last few decades resulted in numerous problems with handling and use of hydrocarbons. Major accidents represent the ultimate most disastrous way in which a petroleum industry projects can go wrong. Accidents cause death, suffering and pollution of the environment and disruption of business. To minimize these accidents, risk evaluation of various installations are actually required to be carried out. There are various methods which are employed in risk assessment. Some of them we have already seen. Just for summarizing for our interest, one such method is what we call as hazard and operability study. The second method is safety and operability study. The other method is preliminary hazard analysis. The fourth method is failure mode effect analysis, and the fifth method is quantitative risk analysis. There are some commonness in these first four methods which is different from the fifth method. The first four methods in the list are actually qualitative risk analysis, because they have some qualitative approaches in their modeling. Some of them also have some semi quantitative approach, but the last one is purely quantitative risk analysis method which is also employed for assessment of risks. In this lecture today we will discuss about the liquid release model based on quantitative risk analysis. Now, make you to understand what is quantitative risk assessment, let us briefly give you some statements. Risk assessment actually is determination of quantitative or qualitative value of risk which is related to a concrete situation and a recognized hazard. Remember, hazard is a scenario, risk is a realization of that scenario. That is why we say risk related to a concrete situation and a recognized hazard. Quantitative risk assessment, which is famously addressed in literature as QRA, is a mathematical approach which requires calculation of two major components of risk. Ladies and gentlemen, can you recollect these two components of risk which are very important? You are right, one is what we call as magnitude of the loss, another is the probability at which this loss will occur. If you look at the QRA method, let us quickly ask a question to ourselves. What do you understand by objectives of QRA? Estimating the risk levels and assessing their significance, identifying the main contributors to the risk, defining design accident scenarios, comparing the design options, evaluating risk reduction measures, demonstrating acceptability to regulators and the workforce, identifying safety critical procedures and equipment, identifying accident precursors and so on. Let us quickly look at the flow chart of QRA. Let us say I would like to see on what basis the study is to be established, what we call as a study basis. You have a problem, you wanted to do a quantitative risk assessment for the problem. First of all, let us establish a basis for that study. Once you establish the basis for the study, you try to look at the risk acceptance criteria for that problem. Ladies and gentlemen, we all understand that the risk acceptance criteria vary for different problems. So, identify the risk acceptable for the case study which you are discussing. If that level of risk is acceptable to you, then further carry out risk reducing measures if reasonably practical and they are cost effective. If the risk assessment criteria or acceptance criteria is not acceptable for you, then the question comes, how do you do a QRA, how do you actually do the risk assessment using quantitative tools. To do that, the first step would be define the system. First, from the case study, identify the case study and then start defining the system, what we call as system definition. For the defined system, identify the hazards. Once you identify the hazards, calculate the frequency of occurrences of that parameters, and if at all they occur, what would be the consequence of that occurrence in the industry. Based on these two quantitative values, calculate what we call as risk picture. Once the risk picture is known to you for a specific case based on the system definition, see whether that risk is acceptable to you. If I say you, I mean to say the management, because acceptable level of risk is a subjective value. The one which is acceptable to you as an individual may not be acceptable to you as a management. So, look at those acceptable levels which are given by international standards. If those risks are not acceptable at all as per the international defined standards, then start thinking of risk reducing measures. Introduce, suggest, recommend some risk reducing measures, again redefine the system for those risk reducing measures in position, then again carry out this picture and check whether the acceptability is now reached. If the acceptability is now reached, then look for, can you do any further risk reducing measures so that measures can be cost effective and reasonably practical. So, that is how a flow chart can be easily explained for a quantitative risk assessment. System definition becomes a very important step in QRA. So, what do you do for system definition? First of all, define thoroughly the installation. Depending upon the case study you are looking for examining QRA, define the total installation of the system. Define the scope of work for your risk assessment. In the scope of work, look carefully for what are the boundaries of your study. In the total installation of the plant, which installation will be included in your study and which you want to exclude in your study. Also look for the phase of installation in the plant. Once you do that, then carry out what we call as hazard identification. Identify different hazards through a qualitative review of possible accidents that may occur. For an identified system, look for those possible scenario of accidents qualitatively, review them, what we call as identify various hazard scenario for the given section of the plant. For this, probably you can use several techniques: hazard review technique, hazard checklist, HAZOP, what if analysis, FMCA, FMEA, etc. Ladies and gentlemen, you will be happy to recollect that we have discussed at least 3 of them in detail, namely hazard checklist, hazard problems and FMEA thoroughly before we come to this module. Let us look at what do we do in frequency analysis. Frequency analysis actually estimates the likelihood for accidents to occur. The frequencies are actually obtained based on analysis of previous accidents, what we call as expertise or experience, or otherwise by theoretical modeling. There are some guidelines available for doing this kind of accident scenarios. CPR 18E is a reference book which contains data related to past few accident scenarios. Then subsequently you do what is called consequence modeling. This evaluates the effects of accidents and their impact, the estimation of the consequences of each possible event has to be done. This can be done either by a computer modeling or based on accident experience or based on judgments if they are appropriate for the chosen problem. We are actually interested in evaluating the effects of these accidents and their impact on the plant. The moment I say effects and impact, you can very well understand we are not focusing only on the impact to human health. We are looking on different aspects of impact of accidents, including the financial loss, including the environmental effect, including the societal risk, all we have discussed in module 1. Kindly look at those lectures once again just to review back what do we mean by impact of any specific accident on the public scenario. So, once you understand the effects of accidents and their impact, estimate these consequences based on software. We will discuss that in the subsequent modules and lectures, based on some accident experience or judgment if you already have and if you feel they are appropriate for the selected problem. As an example, software can be also used for doing consequence modeling. There is a software by DNV which is called FAST. This can be employed comfortably to do what we call as consequence modeling. Alternatively, you can also look for Yellow Book. This has certain models to determine the outflow and dispersion of dangerous substances in the environment, which is given as CPR 14E guideline. You can also look at this reference manual for modeling the dispersion problems. Once you understand the consequence and the frequency, now try to estimate what we call as risk. Compute the risk. Risk is nothing but the product of these two. When the frequency and consequences of each event are estimated, then they are combined to form the measures of an overall risk. So, risk is nothing but the product of frequency of occurrence of any specific event identified and the consequence of that event if at all the event occurs. Risk to life is often expressed in two complementary forms. We have already seen them in detail with the equations available for different international standards. Just for completion's sake, I also wish to put that definitions back once again in a very comprehensive form. Risk to life can be done in two formats. One is what we call as individual risk, other is what we call as group risk or societal risk. Individual risk is that risk experienced by an individual person, whereas societal risk is that risk experienced by the whole group of people exposed to that hazard level. You can also use a software to estimate the risk. For example, Safety is one software which can be used for estimating risk. Once you have the frequency and consequence of the events identified by you. Once you have the risk picture in front of you, we can talk about what we call as risk reduction. Can I really reduce the risk? Now the question comes, when do I look for risk reduction? Can you answer this question? Exactly what you are thinking in mind is correct. First of all, the estimated risk or the evaluated risk is checked whether it is within the acceptable limits or not, what we call as acceptable risk level. Once the risk level is within the acceptable level, then there is no point in applying a risk reduction at all. If at all the risk estimate is beyond the acceptable level, which is defined by international standards and regulatory measures. Remember, acceptance criteria for risk is a subjective value. Therefore, you need a regulatory measure to basically define what kind of risk you are going to accept for your problem. So, once that estimated risk crosses the accepted level of risk for your problem, then the question comes the necessity for risk reduction. So, you should make recommendations in your analysis to bring down the risk to the acceptable level. Then the benefits can also be evaluated by repeating the above process within cooperation of the reduction measures. You also try to work out the economic benefits of the measures and compare them with the risk benefits using what we call as cost benefit analysis. I can also give a very brief flow chart for the methodology which is generally adopted for a QRA. First, try to identify the case study, introduce the case study in detail to yourself, try to collect all possible data required based on the ASAP study and then discussion with the engineers. On the other hand, if you want to really do a quantitative risk analysis successfully, first we must conduct an ASAP study and try to collect all data based on this ASAP study. Based on the ASAP study conducted, try to identify the hazards present in that specific case study, try to see the data required to input for risk analysis software. So, this very clearly tells you that you should be aware of using any standard software which does risk analysis. So, look at the software, learn the basic tools available in the software, see in what format the data is requested in the software and try to see what input actually you need to use the specific risk analysis software. Once you get the results as an output from the risk analysis software, process the risk analysis calculation and then the release scenarios. Based on the release scenarios, make what we call as a risk presentation, which will be nothing but an hazard curve or a risk presentation curve. We will prepare an output in a graphical format and based on that level of risk evaluated from your case study, check whether they are within the acceptable standards of the company or the regulatory measures, then give subsequent recommendations to reduce the risk to the acceptable standards. Ladies and gentlemen, it is a very simple flow sheet to do what we call as QRA. I can give a very typical example of a typical output what you get from a software if you do a QRA. This example shows an output of a QRA study conducted for a leak of a pipeline in terms of radiation intensity for a jet fire consequence. Look at this curve, this is expressed in a graphical format. The release direction in terms of meters is being given and then the width of the spread in terms of meters is being given. This is actually a data sheet which we have been using for analyzing a leak of a pipeline. The weather condition is considered, the material leaking is basically a crude oil and you can see here is the wind direction. Then there are 3 ellipses you get, one is a cyan, one is in red color, other is a green color. Of course, you can change these colors depending upon your requirement or protocol of the company. So, what we want to emphasize here is very simple. The ellipse area tells me that the radiation intensity in this segment is about 37.5 kilowatt per square meter, whereas in the green segment and in the red segment subsequently they are 4 kilowatt per square meter and 12.5 kilowatt per square meter respectively. So, what you get from QRA using a software is a typical output of this kind. Graphically, you will also get an output on literary means, which we will discuss in a specific case study subsequent to this lecture. There are obviously some limitations on QRA studies. Before we perform actually a QRA for a case study, which will be quite interesting for you to learn, let us clearly accept the limitations of the study. Now unfortunately, different approaches give you different results. The scenario selection depends on the expertise you have on the specific problem. The change in environmental conditions, for example the operating temperature or the ambient temperature during the release of the liquid or a gas, the humidity conditions present at that stage or state of release, and of course the wind direction and speed can subsequently alter the computed results which you have estimated from your QRA studies. Each software model simulates different results for the same release scenarios. This is very interesting for you to know that there is no unique answer what you will get for a release scenario if you use different software models, though there are some commonness, there are some common results which you will get from almost all software, but there is no guarantee that each and every software model will simulate the same kind of result which is going to be common through and through for all software models. That is not true, and unfortunately the acceptable risk limits vary widely for different countries. So we put it the other way, all countries do not have statutes specifying the acceptable risk limits. It is a very careful sentence. There are many countries which even do not define an acceptable risk level at all for a petroleum company. The database which you use for the probability estimates can be subjective and can be different as well. So these parameters will strongly influence the results what you obtain from your study conducted on QRA, what we put them as limitations of QRA. We will discuss one specific case study of quantitative risk assessment now. The case study what I am going to examine is nothing but a group gathering station. You can recollect that we have already done an HAZOP study for a group gathering station which is discussed in detail in module 1 lectures. I am looking the same example again. Now I am going to perform a different mode of study. The HAZOP study what I conducted for a group gathering station case was a qualitative analysis. Now I pick up the same example and demonstrate to you how can you do a quantitative risk analysis for that. So I am picking up the same example actually. The objective is to actually identify and assess the hazards and then subsequently the risks that arise from daily activity of what we call as a GGS. I am actually interested to eliminate or to reduce the risk to a level as low as reasonably practical, what we call as ALARP level, in terms of risk to human health, risk of injury, risk of damage to the plant, equipment and environment, business interruption or loss, etc. So ladies and gentlemen, please understand that the risk is not only related to human health. It includes injury, not a fatal. It includes damage to the plant also, which is a capital loss. It includes damage to the equipments, which is again a capital loss. It includes risk to the environment, which is again a legal issue. Also any business interruption created due to the risk is also considered as a loss. So when I say risk assessment, I am analyzing or I am assessing overall in a very broad scenario of many things. It is not only human health. Then subsequently I must give recommendations to the management to comply with regulatory measures and the company policy and the business requirements. So the outcome of any case study which we will discuss as QRA should result in list of summary which is say as recommendations to the management, and those recommendations cannot be very subjective and very funny. They should be complying with the regulatory measures, international standards, and also they should strongly follow the company policy. Remember that any risk mitigation or reduction is always initiated with a willingness from the company or the management. Every company has a business policy. You must always appreciate and respect the business policy of the company, business requirements of the company, then accordingly chalk out the recommendations in your QRA study. What are the steps involved in a QRA study? The first step obviously is identification of hazards and the major loss of containment events, what I call as LOC. In a given problem, I try to identify what is the major loss of containment and what are those events responsible for this kind of loss, and also identify the hazards related to that scenario. Then calculation of physical effects of accidental scenarios, consequence analysis for the identified hazards, then damage limits identification and quantification of the risk in terms of frequency, and then contour mapping on the layouts. I will also look at independently the individual risk quantification and the societal risk quantification, which I am trying to explain in terms of graphical representation. All softwares, ladies and gentlemen, in general give the output of risk quantification in terms of graphical representation, and ultimately the hazard mitigation recommendations based on the QRA what you study. As I clearly emphasize, the recommendations what you make as a QRA analyst should comply to international regulations, and of course it should respect the company business policies on which you are employing the study. Remember this statement, this is very important, otherwise your recommendations will go in vain, because risk mitigation or reduction actually is a willingness process from the company. Now you have some preliminary requirements to carry out this study. Let us quickly see what are those requirements. You must have what we call piping and instrumentation diagram, which I call as P&ID. This P&ID should indicate clearly the design and operating conditions. Then I must have what is called process flow diagram, which briefly I call as PFD. Then I must understand completely and thoroughly the operational and control philosophy involved in the segment of the plant. I must have a complete layout drawing which is thoroughly drawn to scale for my problem. I should also have the complete details of the fire detection systems and the protection facilities available in the near vicinity of the plant. Remember that we are not only focusing on the risk reduction measures available in the plant itself, but also in addition we are looking for those protection facilities available in the near vicinity of the population as well, and also try to find out all details available on emergency shutdown system if applicable to your study. And very interestingly, you must have the details of population, the density of population in the vicinity of the problem where your plant is situated. Now I have a similar case study with me. This figure is as same as what you saw in one of the lectures on hazard study in module 1. I am recollecting the same figure once again for the benefit of the viewers. I am having a process flow diagram now on the screen. Now I have made a small modification in this process flow diagram. I want you only to look at that modification or draw your attention only to that. If you look at this figure very clearly, I have numbered them in a scenario of 1, 2, 3, 4, 5. They are in blue color. The other scenarios are 6, 7, 8 and 9, which are in red color. Ladies and gentlemen, can you really find out the difference between the numbering 1 to 5 and 6 to 9, because they are in different colors? It is very simple. The numbers or the events related to 1 to 5 are something related to the piping or the piping system. The numbers from 6 to 9 are related to the tanks or the vessels. For example, 6 is an assessment on bath heater, 7 is on jumbo heater treater, 8 on the ER tanks and 9 on the storage tanks. So, I am looking QRA on 2 distinct levels. One is on the pipeline segment of the whole problem, starting from the group header to the CTF. The other is on the vessels or the tankers where my process is taking place. Is that understood? So, this is going to be a base of the process and flow diagram, based on which I am going to do a quantitative risk analysis. I have already done a qualitative risk analysis for this, which I addressed as HAZOP in the first module lectures. There are some salient features of the GGS, let us quickly go through that. The facility actually is designed to process 1100 cubic meters a day of oil. In addition to that, 1000 cubic meters a day of a separated water and the corresponding associated gas, which we call as GOR, to a maximum of 10 V by V. Now, the feed characteristics of this plant are the following. The fluid pressure is about 10 kg per centimeter square and the temperature operation is about 50 degrees Celsius. The product specifications are as follows. The treated oil has a specific gravity of 0.97 at 15 degrees Celsius. The APA grade is about 14. The viscosity is about 12,600 Cp at about 25 degrees Celsius. The separated water has a specific gravity of 1.0. The viscosity is again 1.0. The pH level of the water is about 6 to 9, it is basically alkaline, and the temperature is about 75 to 80 degrees Celsius. The associated gas in this process is comparatively negligible, therefore, I am not focusing on this at all for this specific case study. So, now you have, ladies and gentlemen, the process and flow diagram. You have understood the flow philosophy completely, you have understood the salient features of the plant. Now, we are prepared to do a case study in the next lecture. Thank you.